Yes, you want to write both of these because they're saying the same thing. Exact same thing. The deal is, this is where they're different. They're saying the same thing. This is where they're different. There's a worksheet. Yes, I'm going to have these online. Oh, is there going to be the outline of online? Is this going to be the video? No, because it's only going to be on video format. Yeah, it won't be, because I haven't, this is brand new. But it will be on a video. All right, so this is saying the same thing. That's what I want, because I've worded two of them like the top. I've worded two of them like the second one, but it's referring to the same thing. We're locating Z, and it's got to be 2/5 the length of the whole segment from vertex A, or point A. And now, how did I say from A without saying from A down here? Do you see that Z is with A? That means from A. Here I said from A. The fact that this is AZ means that it's from A. If this had been BZ, that would have been from B. All right, so these are the step-by-step instructions on how to do it. And I think what I'll do is I will write the directions and then do each part of it. And again, these are the exact same problem. These are the exact same problem. All right, so number one, I'll do notes in black. Step 1, you must find the length, of the segment. How do we do that? That was the absolute value of A minus B, if you remember that. This bothers me. That should be lowercase. Sorry. All right, so you must find the length of the segment. So if I were to draw a number line, which is really helpful, it's very helpful to see. B is at -4. There's B. A is at 6. So if I want to do step 1 for this problem, the length of AB is going to be the absolute value. What do I subtract? -4 minus 6 is, or -10 or 10. Now, if you chose to do 6 minus a -4, you're going to get a positive 10 in the absolute value, which is still 10. So does it matter when we have absolute value how you subtract? Okay. Do you have to do it both ways? No. Any questions on the first step? Yes. Any questions on the first step? Yes. They're the same problem. Same problem. This, what's highlighted in yellow, is worded differently, but it means the same thing. It's the same problem.
Wait, I have a question.
Oh, yes.
They're going to give you, like, they're not going to give you X minus, like, they're not going to give you, like, algebra questions.
No, this is not algebra. It's all arithmetic. Okay? All right, now, next step, number 2. You must find the fractional length. Fractional length of the answer to 1. And how do we do that? Let me do this in a different color. You will say fraction times, that's multiply, answer to number 1. That's how you do that. Is there a fraction? Okay? You're given a fraction. So you're going to say 2/5 the fraction. What's the length in problem 1? Oh, so now that's going to be 20/5 or what? 4. That means that 2/5 of the length of 10 is 4. That's a length. That is not a coordinate. So we want to find z so that it is between A and B. But now this is where the yellow comes in. This says from A. So here's A. Now, I have to move 4 units. I'm either going to move to the right or I'm going to move to the left. Remember, we must be on the segment. So we must, in this case, where? Okay. So now step 3, you will add or subtract, and I'm going to get a little bit more definitive there. You must add or subtract the answer from 2 from the appropriate endpoint. Okay? So, when do we add? You add when you move to the right or when you go up. When do you subtract? When you move to the left or you go down. Very, very, very important. This is an important piece right there. And you all told me we had to subtract, not add, because we have to move to the left. So now, what does this, let me get another color. What does this mean? Add or subtract the answer from number 2, that would be 4, from the appropriate endpoint. What's the appropriate endpoint? What did it tell us? From A. Now, how else could it be worded? Look at this. AZ. Here is A. Z is going to be somewhere here because A is with Z, it's from A. If that had been BZ, it would have been from B.
So it's asking the exact same thing.
Exactly, and differently though. It's the exact same thing, but in a different way. So we're going to say 6 minus 4, because we're moving to the left, is 2. In other words, Z is at 2. 2 is not a length, it is a 4, 6, 5, 4, 3, maybe 2 is approximately there. There's our 2, and that's my Z. I put a dot on A because we're doing from A. Pardon? If I had, okay, the answer is 2. If I had done this one, the answer is still 2 because I have to take A, which is 6, and move to the left 4 units, and I'd be at 2. Okay. Those 2 problems are exact. These 2 problems are the same thing. Those 2 problems are the same thing. I just did the work for both of them at the same time. All right. No. Now we're going to take this to the coordinate plane. All right. So we're going to do the same thing on a coordinate plane, but how is it going to be worded on the coordinate plane? Let's say find a point. Find the coordinates of point. Find the coordinates of point R that is 2/3 the length of AB if A is at 2, 3 and B is at negative 4, 12. Find the coordinates of point R that is 2/3 the length of AB, and I'm going to say from B. And again, This one could be worded like the last one, where I say RB, such that the segment RB is 2/3 the length of AB. So the first thing you're going to do when you have these, and you have to have graph paper. I did it without graph paper, and I messed it up. All right. I was working with someone before after school, and I messed it up because I did not use graph paper. Yes. It's across the room, unfortunately. Yes. All right, so I've got 5 minutes, so let's do this. You ready? Okay, while you get out graph paper, I'm going to plot 2, 3 and label it A and label it 2, 3. And I'm going to find B, which is -4, 2, 4, 6, 8, 10, 12. So make sure your x-axis is really low because I went really high. This is B, and that's -4, 12. So my segments, let's make my segment look something like this. Here's my segment. All right, it's really important that you graph it because when you're finished, those coordinates should fall on that segment. If they don't, you know you've messed up. And I knew that I messed up on several of them because they did not fall on my segment. All right. Now, all this is the what we just did 2 times. This is the deal. You work with x's independently of y's. So B, if I take B to the x-axis, it's there. And if I take A to the x-axis, it's there. So we're going to ignore everything above it. What is this? What are these coordinates? What is this number? Negative what? -4. What is this number? 2. So we're going to deal with the x's just like we dealt with the number line. Pretend like at this point we're not on the coordinate plane. The first thing we're going to do is we're going to say 2 subtract -4. That's the length of the whole segment, right? That's x's, x, apostrophe x.
Wait, how is that? X, 5?
No, that's an s. Those are x's. And then we're going to work on y's. Do you see that? Those are x's. You know, like x apostrophe x, s? All right. So this is 6. Now, what's the fractional part? So we're going to say 2/3 times 6 over 1 is 12 over 3, which is what? 4. Now, am I going 4 units from B or from A? What does it say?
From A.
What does it say? From B. So here's B. I have to move in what direction to stay in between? Right. So what do? I take my -4, I add 4 to it. That's my B, and I get 0. So what I have so far is I have half my answer. This is point Z. Okay? I'm sorry, this is R.
You're going way too fast. What do you mean 2 seconds?
Didn't I ask you for point R?
2 seconds. Oh,
I don't have 2 seconds, but they will be online.
Dude, I don't got.
Dude, I'm not a dude. So now what we're going to do is we're going to do the same thing for the y's. All right? So what is this y value? This y value is 3, and this y value is 2, 4, 6, 8, 10, 12. So now I'm working this way. So how do I find the length? Length?
3 minus 12.
3 minus 12 or 12 minus 3. When we're doing length, we are subtracting. So now once I get that length, what's my fraction?
9.
I want 2/3 of 9.
Whoa, what do you?
Which is going to be 18/3, which is what? 6. Now, am I moving 6 units from B or 6 units from A? I'm moving 6 units from B. So B is up here. So am I going to go to stay in between these two numbers? Am I moving up or down? So if I'm moving down, what do I have to do? So I take the 12 and I subtract my 6, and what do I get? So my ordered pair for R is 0, 6. Now, if you plot that, if it doesn't fall in the segment, we messed up. So here's 0, 1, 2, 3, 4, 5, 6. This distance is 2/3 the distance from A to B. All right. So the only thing that the only problems you can do on this worksheet, it's the same 3 steps. On the coordinate plane, you've got 2 problems instead of 1. On your worksheet, the only problems you can do are 1 through 4 and 7 through 10. Okay, 1 through 4, 7 through 10. I want the coordinate plane ones on graph paper. All right? And let me tell you, the key on the coordinate plane is to literally drop it down to the x-axis and play here, and literally move it over to the y-axis and play there. Because what we've done is we've taken a diagonal segment and we've broken it into its components, so we're working on what we did initially. This is CC1, no, CC1.